In this video, we'll go over section 5.6, and this section is very short. The arith value of the definite intervals. Now, recall from your algebra class, if you have some numbers, right? For example, you have numbers 5, 6, and 20. Now you want to find the arith value of these three numbers. You add them up all together, divide by 3. And 3 here is the total number of different elements you have here. In this case, we have 3 different numbers. What if now we have a function, and a function is changing or varying over the time? In this case, f of t represents for the temperature function of the function t, and of course it is not a constant or a single number where we can just add all the numbers together and divide by how many number that we have. But this is the whole function. How do we find the arith value or the arith temperature in this case? First thing is, on the interval from A to B, we can subdivide that interval into small sections. I may call that point T1, T2 up to Tn. Now you add all the value of that function at those points and divide by the n value that you have here, and that should also give you the arith temperature. But the more you have the points, the better the value that we get for the arith temperature. For example, if we just have T1, T2, T3, T4, or T5, so that we only have 5 points, you still get some arith value, arith temperature, but the value may not be accurate compared to someone that is taking 15 or 20 points. Then their answer should be more accurate comparing to the true value. Now, being said that, if I have the time from 0 to 24 hours and I want to find the arith temperature of that function, now this interval is from 0 to 24. A is 0, B is 24. Delta t is b minus a over n. B in this case 24, a 20, a is 0. So 24 minus 0 over n is 24 over n. Now you can solve for n is 24 over delta t. The arith temperature is what? Is you adding up all the points t1, t2 up to tn of that function f, and you divide by the total number of n. In this case, n is 24 over delta t. Now, because you are dividing by fraction, we are flipping the delta t to the top. So any delta t, you are multiplying that to here, here, here. You got here. Now, all these things, we can represent them using the Riemann sum or the summation formula of the time t1 up to tn. So we go the index I from 1 to n because we are having t1 up to tn. So f of ti, I go from 1 to n, and we are multiplying each of them by delta t. And don't forget to divide by 24. Now, when your n is approaching to infinity, this summation formula turns into the integral from 0 to 24 of that function, and we still have 1 over 24 in the front. So this whole thing turns into the integral if n is approaching to infinity, and this is called the arith value of a function f over the interval a to b. So in general, any function f can have the arith value from the point a to b by taking the integral of that function from a to b, dividing by b minus a. And we can visualize that on the graph by drawing out here. So the integral of the function from a to b of that function f represent the area under the curve. In this case, the static region here is the integral here, because it's represent for the area under the curve, which is here. Now this thing dividing by b minus a give you the arith value. So if we have f of x to be a positive function here, then the arith value of f is the height of a rectangle whose the base is b minus a, and whose the area is the same as the area between the function and the x axis. So that should give you the arith value. So let me draw that for you to see here. Okay, so this thing is the arith value. So the arith value has the base of b minus a, and it has the area. So let me show this new area here. So this new area of the rectangle is the same area of the graph under the, of the region under the curve of function f of x, and this has the height of the arith value. So this is the arith value of the whole function with the base of b minus a. So we know that. Now we can try a few problem example. Okay, so let's try the first example. Suppose that c of t, this represents for the daily cost of heating your home, your house, in dollars per day. Okay, now t is in day, and t equal 0 is represent for the January 1st of the year 2010. Now you want to interpret this expression 0 to 90 and c of t dt. Okay, we are given the function c of t. This is the cost of heating your house, and this c of t has the dollars per day. T is in days. Now you want to interpret this whole expression. So the first thing is 0 to 90 c of t dt. C of t has the units of dollar per day, right? So here is dollar per day. Now dt has the same units with t, which is day. So we cancel this guy. That means the integral of this whole thing will give you the unit of dollar from 0 to 90. Okay, so this one represents for the total cost in dollars to heat your house for the first 90 days of 2010. Total cost for heating from day 0 to day 90 of 2010, or the first 3 months. So the total cost in dollars for heating your house the first 3 months of 2010. But we have something else. 1 divided by 90 minus 20. So we have to multiply by that. So that would give you another value. So this is similar to this is A, this is B, this is A, right? This is values B, this is A. So if you multiplying by this thing in front of the integral, you should get the average cost, because this one is the unit is in day, 90 day, 0 day. So you have dollar here, then you multiplying by 1 over day, right? So dollar per day again, which is the average cost. So the whole thing here represent for the average cost to hit your house during the first 90 days of 2010 in dollars per day. Now let's go to another example. Second example. The population of McAllen's Texas can be represented by P of T equal F of T equal 570 1.037 to the T power. Now P is in thousands of people, right? And T is the year since 2000. Okay, now you want to estimate the average value or the average population from the year 2020 to 2040. Okay, so they give us the interval from 2020 to 2040. This is A, this is B, right? So we can estimate the average population by using the formula 1 over B minus A, which is 2040 minus 2020, and multiply by the interval from A to B, and the function f of t dt. And of course you can use your graphing calculator to estimate this, and it should give you 1732.81, or this is in thousand, right? Because this is the thousand of people, because we are given a unit in thousands. So about this is 0.8, so about 1733,000, so 1,733,000 people. So this is the average population from 2020 to 2040. So that's the end of section 5.6.